Hi everyone, my name is Rory Neary and welcome to my course Power BI Data Import Playbook. I'm a Power Platform consultant at Data Spinners and I've been working with data as an accountant, analyst and developer for over 20 years. This course is relevant to almost every single Power BI report that has ever lived. Not only that, but connecting to data is very often the first place you're likely to begin when starting a new report. So, if you're starting out with Power BI, you've come to the right place. In this course, we're going to cover the creation of connections from Power BI to a very wide range of sources of data. Some of the major topics that we'll cover include connecting to databases, Excel files, connecting to online sources, and creating tables from thin air. By the end of this course, you'll know how to import data into Power BI, and you'll also have an understanding of the importance of where to store your data files. Before beginning the course, you should be familiar with Windows operating system, and it will help to have an understanding of data modeling concepts such as tables, fields, and relationships. You're also going to need an installation of the Power BI desktop, which can be downloaded from powerbi.microsoft.com. From here, you should feel comfortable diving further into Power BI with courses on Retrieve, Transform, and Combine Data using Power Query and getting started with DAX formulas in Power BI, Power Pivot, and SQL Server Analysis Services. I hope you'll join me on this journey to learn Power BI with the Power BI Data Import Playbook course at Pluralsight. Hello everyone, and welcome to the Power BI Data Importation Playbook. My name is Rory Neary and I'm a Microsoft Power Platform consultant for Data Spinners Limited. Before we go too much further, we need to understand how import fits within the Power BI model production process. In this overview, we're going to look at what extract, transform and loading of data actually means. We're going to look at how Power BI get data isn't the same as Power BI import. And finally, we're going to take an overview of potential data sources that can be used within Power BI. So what is the Power BI ETL process? Firstly, it starts with E for extraction, that is, obtaining data from your data sources, and that will be the centre of this course. Once you've extracted your data, you'll need to transform it in some kind of way. That could be filtering the data or pivoting it in some way. Finally, you're going to need to load your data into your data model so that you can make your amazing data visualizations. Let's now consider Power BI terminology for a moment. Import isn't necessarily what you think it means. In the case of Power BI, when you go to File Import, you'll see custom visuals and you'll also see Power BI templates and even Excel workbooks where you can extract queries. But it's not the same as Power BI Get Data, which is where you'll need to go in order to go and get data from your various data sources, whether or not it's Excel and CSV databases or anything else. We're now going to take a look at the Power BI extract, transform and load process. We're also going to make a comparison between Power BI import and get data. We're going to do this via an extract from Excel. We're then going to do some transforming of the data, and finally we'll load the data into the data model. We'll then go on to create a visualization using our data model within Power BI. So here we are inside Power BI. We're going to go up to the File menu and take a look at Import. When we go on to import, we can see that we've got a number of options. We've got custom visuals of one kind or another, and there's also Power BI templates. And finally,
Hi everyone, my name is Abhishek Kumar with Pluralsight and welcome to my course on doing data science with Python. Data science is one of the hottest fields these days, and no wonder data scientist has been termed as the sexiest job of the century. Because with the help of data science, you can unravel meaningful insights and generate data-driven evidences that can benefit organizations in a significant way and provide them competitive edge. So if you also want to make a jump start in this fascinating field of data science, or if you are already in this field and want to learn the standardized way of tackling end-to-end data science project cycle using Python, then this course is for you. In this course, we will dive into various phases of a data science project such as data extraction, data processing and visualization, building, evaluating, and fine-tuning predictive models, and finally exposing your predictive models as APIs for real-time integration. The only prerequisite to this course is that you should be familiar with basics of programming with Python. This course will not only your predictive model and fine-tuning for real-time integration. The only prerequisite to this course is that you should be familiar with basics of programming with Python. This course will not only help you to build the foundations of data science, but also help you learn to implement the concepts through lots and lots of demos. By the end of this course, you will be in a position of knowledge and skills necessary to kickstart your data science journey in the Python world. So please join me on this very exciting course on doing data science with Python at Poolside. Hi, this is Abhishek Kumar and welcome to this course on doing data science with Python. Data science is one of the most exciting fields these days, and one of the key reasons behind this excitement is the massive amount of data that is getting generated across the world. Looking at some numbers, currently the whole world is generating roughly 2.5 quintillion bytes, that is 2.3 trillion gigabytes per day. And with this rate, the world will generate approximately 40 zettabytes, that is 43 trillion gigabytes of data by the year 2020. Not only this, the data is getting generated from multiple sources, such as transactional data from various enterprises, or process data from various industries. Data is also coming from various social networks in the form of tweets, posts, videos, or images. It is also getting generated through internet connected devices, also known as Internet of Things. But whatever be the data, it is of no use if we cannot extract some value out of it. And there comes data science into the picture. So what is data science? Well, broadly speaking, data science provides a set of fundamental principles that guide the extraction of knowledge of data. And the companies around the world are using these principles to gain edge over their competitors by extracting valuable data-driven insights and creating value-added data products. And this makes data scientists as one of the most desired assets for the companies, as they can help companies to generate valuable insights and patterns from data. No wonder Harvard Business Review has termed the data scientist as the sexiest job of 21st century. So if you are also interested in the field of data science and want to learn how to extract knowledge and patterns from data, then this course is for you. In this course, we will learn to cover the path from raw data to meaningful value and insights through different stages of data science project cycle. Along with the basics of data science project cycle and its components, you will also learn to tackle different stages using Python and Python-based tools and packages. And the best way to learn something is by doing your hands dirty. Therefore, we will take various hands-on exercises so that you can follow along with me and learn to use these Python tools to tackle real-world data science problems. Along with several small exercises, there will be an overarching case study that will encompass the rest of the modules, where we will take a raw data set and then we will work on it step by step. This case study will help you to connect different dots, and you can use this case study as a common framework for your future data science projects. You will also learn some of the best practices for tackling data science projects and problems. This can be very fruitful for you in the long run. I will also provide some tips and tricks along the way that can be very handy at times. The case study we will take in this course is related to Titanic disaster. We will use this interesting dataset to go through each stage of the data science cycle one by one. I'm sure you must have heard of Titanic disaster that happened way back in 1912 when the Titanic ship sank after colliding with an iceberg. In this disaster, almost 1,500 people died out of roughly 2,200 passengers, including crew members. We picked up this case study due to a couple of reasons. First of all, as most of us are aware of this incident, therefore there is no specific domain knowledge required to understand this case study. Another reason is that this case study is both simple and complex at the same time. Simple because it has smaller number of variables and you can easily understand the problem. Also, you can get good results with relatively simpler models. But at the same time, through this simple case study, we will unveil the complex nature of complete data science project cycle. Not only this case study is also a Kaggle competition challenge. Those who are not aware of Kaggle, it is a very famous platform for machine learning competitions. So towards the end of the course, we will also see how you can participate in kaggle competitions. This can be very effective as you put your knowledge and understanding to a real world challenge. You can also apply the learnings of this course to tackle other exciting data science problems too. So if you're also excited about data science just like me, then buckle up and hop onto this roller coaster ride to take a dive into this very exciting field. This course is targeted for both data science aspirants as well as data science professionals. On one hand, this course will help data science aspirants to know everything they need to know to make an elegant entry in the data science world. On the other hand, data scientists and the data professionals who may be using different set of tools or framework will learn the usage of Python-based tools and packages to accomplish their data science related tasks. So this leads to a very important question, that is, what are the skills required to follow this course? Here are the course prerequisites. As this course is built on the Python language and framework, so the basic understanding of Python is required. You do not have to be a Python guru to follow this course, as we will be using only some basic Python constructs in this course. But if you are not comfortable with Python at all, then you can take any Python fundamental course. Few great Python courses are already available in the Pluralsight library, so you can take any of them. Also, this course will assume that you know some basic high school mathematics. Don't worry, we will not be talking about advanced mathematical concepts in this course. And if you have some background knowledge of statistics and machine learning, then you will be rocking during this course. But even if you do not have such background, then don't be scared. I'll explain all the related concepts to you so that you can easily follow along in this course. And in case you face any trouble while understanding any concepts or code, then you can always post your queries in the discussion forum and I'll try to reply back as soon as possible. So now we have set up our expectations, let's dive into the data science world and have an overview of the data science project cycle and its components. So as mentioned previously, data science helps us to make a journey from data to valuable insights. But it has several components along the way. Let's examine these components one by one from the bird's eye view perspective. The first piece is the extract phase. We need to get the data first before we do anything with it. Data extraction or data acquisition is the first step towards our data science journey. Data may have to be acquired from one or multiple sources. Once we have extracted the data, the next building block is to organize or pre-process the data, because rarely you will get data in the required format. You may have to perform various data wrangling tasks to clean it and then put it into a right shape. Once we have organized the data, our next step is to analyze and create model. As you can see, we have used a cycle or loop kind of thing here because it is an iterative step. In the real world setting, you may have to try different models and then analyze them and evaluate them over and over again till it reaches a desired level. Once you have your model and analysis ready, then the next step is to present the results. Results could be in different formats. It could be a report or presentation that you may want to show to your stakeholders. It could be a blog or websites that you want to put it on the web. It could even be an application that has to be deployed in a production environment. But many times it can happen that the key insights you have drawn through all these steps are not good enough and you may want to further build upon it. Then you may have to repeat this whole cycle again with some new and additional data with different processing or different analysis or modeling techniques or different approaches of presenting the results. So this outer loop is used to represent the iterative nature of the whole data science cycle. This shows that it is a continuous ongoing activity where you incrementally build upon your previous works. Now the next and very obvious question is that why we have picked up Python for tackling this data science project cycle in this course. What benefits does Python provide for data science work? Let's address this key question in the next clip.
So what are the reasons behind Python's rapidly increasing popularity for data science projects? Let's see few of the key reasons here. First of all, Python as a language itself is fairly easy to learn as its syntax is similar to other common languages. Also, Python code are also easy to read and are quite intuitive in nature. Another key reason for Python popularity is the availability of various open source free tools and libraries for various data science related activities. These tools are very helpful in making a head start with data science projects. You will find a complete ecosystem in Python stack for data science related activities right from the extraction phase to the presentation phase of the data science project cycle that we have seen in the previous clip. We will learn about several such tools and packages in depth during this course. Also, in the real world, we will face issues and challenges during our work and may need help. Python has a very strong and active community, and you can easily get help if you run across any problem or issue. Python is also quite fast and scalable with respect to some other languages and frameworks that are typically used in data science world such as MATLAB or Stata or R. I will not say that the Python is the most scalable and the fastest language in the world, but there is a very active push in the area of scalability by the developers, researchers, and the community to make it even more faster. Last but not the least, what makes Python great is its ability to get into the production environments, especially for companies that are already having Python-based application stack. So your data science projects don't have to remain on your personal laptops. It can get into the production environment and can be leveraged to create meaningful data-driven products or applications. So now we have set up our expectations for this course. Let's look into the course outline in the next clip to see how we have structured this course for you. Here is the course outline. We will first set up our working environment in the next module. You will learn about various Python distributions that are typically used by data scientists. You will also learn to set up Jupyter Notebook on your local machine. Along the way, we will also explore some of the basic features and tips and tricks of Jupyter Notebook. Further, we will talk about some of the best practices such as following a data science project template and using a versioning system. Then, Module 3 will be focused towards data extraction phase, and we will learn how we can extract data from different types of sources, such as databases, publicly available APIs, and websites through web scraping. We will also extract the Titanic dataset in this module that will be used in the consecutive modules for exploration and building predictive models. From the tools perspective, we will look at a bunch of Python libraries, including several database connectors to connect to different databases, and request library to work with APIs. We will also use another very popular Python library, Beautiful Soup, for our web scraping work. Then we have 3 modules dedicated on the organized tab where we will cover various aspects of exploring and processing data. In the part 1, we will focus on basic exploratory data analysis techniques using Python tools such as NumPy and Pandas. Then, in the second part, we will focus on advanced analysis techniques, and along the way, we will learn several useful Python NumPy and Pandas functions. In the third part of the Exploring and Processing Data series, we will talk about several techniques for data munging, where we will identify different issues in the data and resolve the issues using standard techniques. You will also be taken to the interesting world of feature engineering and will also learn to create compelling visualizations. From the tools perspective, we will extend our NumPy and Pandas journey And we'll also learn another very useful Python library, that is matplotlib. After data exploration and processing, we will get into the exciting world of predictive models that we will cover in two parts. In the first part, we will work on the foundation of machine learning and will build and evaluate basic machine learning models. We will also submit our predictions to Kaggle platform as the part of the presentation phase. And along the way, we will leverage the Python scikit-learn library to accomplish our goals. Then, in the second part, we will learn some important concepts related to model tuning that will help us to fine-tune our model performance. We will also learn ways to take the machine learning model to production setup so that your machine learning model can be a part of full-blown data solution. In this direction, we will cover the model persistence to persist the trained machine learning model to the disk, and then we will also develop a machine learning API on top of it so that it can be integrated with any system. In this module, other than the Python scikit-learn library, we will also cover a couple of useful Python libraries. So we will use Pickle for model persistence and Flask to develop the machine learning API. So as you can see, we have lots of fascinating stuffs to cover in this course. So let's get into the exciting world of data science.
StatQuest is special. Yes, it is. StatQuest. Hello, I'm Josh Starmer and welcome to StatQuest. StatQuest is brought to you by the friendly folks in the genetics department at the University of North Carolina at Chapel Hill. Today we're going to be talking about quantiles and percentiles, and they're going to be clearly explained. I thought putting this StatQuest together was going to be super easy, but doing a little research sent me down a crazy rabbit hole. Pretty much every web page I looked at had a slightly different explanation. Part of the problem is that there's a difference between how the word quantile is defined and how quantiles are used in practice. The other problem is that there's a ton of different ways to calculate quantiles. The quantile function in R alone has 9 different methods. Let's start by talking about the strict definition of quantile, and then we'll move on and talk about how the word is used in practice. If you can recognize the definition, you can skip it and move on to something more useful. We'll start by measuring expression for a gene. Then we measure expression for another gene. We measured expression from 15 genes total. This is the median value. 50% of the genes have higher expression, and 50% of the genes have lower expression. Technically speaking, the median is a quantile because it splits the data into groups that contain the same number of data points. In this example, there are 7 data points below the line and 7 data points above the line. Sometimes this quantile, the median, is labeled 0.5 since it splits the data in half, and sometimes it's labeled 50% since 50% of the data is above it and 50% is below it. The median value is 4.5. Thus, the 50% or 0.5 quantile value is 4.5. To summarize this first point, the median is a quantile because it splits the data into equal-sized groups. This is called the 0.5 quantile or the 50% quantile. Regardless of which notation is correct, you're likely to see both of them in the wild. So let's just roll with it and not get too bent out of shape over the nomenclature. Now we've added 2 more lines. Together with the first line, they divide the data into 4 equally sized groups. These new lines are quantiles because they divide the data into equally sized groups. This one is called the 0.25 or 20 StatQuest, StatQuest, StatQuest. Hello, and welcome to StatQuest. StatQuest is brought to you by the friendly folks in the genetics department at the University of North Carolina at Chapel Hill. Today, we're going to be talking about heat maps. I know you've seen them many times before, so let's just get started. Here's a heat map that I drew for a friend of mine not too long ago. The rows are genes, and the columns are RNA-seq samples. The data displayed in this heat map has been modified in two ways so that we can gain some insights from it. The first way is that the relative abundances have been scaled. In this case, this was done on a per-gene basis. Other heat maps you've seen out there scale all the genes at once. Anyways, this makes it easy to see that sample X has more or less of gene Y than sample Z. For example, the scaling makes it easy to see. I know you've seen them not too long ago. The rows are genes, and the columns are RNA-seq samples. The data displayed in this heat map has been modified in two ways so that we can gain some insights from it. The first way is that the relative abundances have been scaled. In this case, this was done on a per-gene basis. Other heat maps you've seen out there scale all the genes at once. Anyways, this makes it easy to see that sample X has more or less of gene Y than sample Z. For example, the scaling makes it easy to see that sample 1 expresses this gene highlighted in the black box more than the others. However, this specific gene-by-gene scaling means that we can't compare across genes. The dark red bar in sample 1 for this gene doesn't mean that sample 1 transcribes it more than other genes, just other samples. The other modification that was done to this data is that the rows, that is to say the genes, have been grouped according to similarity. This grouping, or clustering, makes it easy to see genes that are transcribed most in the second sample and least in the fourth sample.
Let's have a look at heat maps. Heat maps visualize data through variations in coloring. When applied in a tabular format, heat maps are useful for cross-examining multivariate data through placing variables in the rows and columns and coloring the cells within the table. Heat maps are good for showing variance across multiple variables, revealing any patterns, displaying whether any variables are similar to each other, and for detecting if any correlations exist in between them. Typically, all the rows are one category, labeled displayed on the left or right side, and all the columns are another category, so the labels are displayed on the top or bottom. The individual rows and columns are divided into subcategories, which all match up with each other in a matrix. Subcategories, which all match up with each other in a matrix. The cells contained within the table either contain color-coded categorical data or numerical data that is based on a color scale. The data contained within a cell is based on the relationship between the two variables in the connecting row and column. A legend is required alongside a heat map in order for it to be successfully read. Category Historical data is color-coded, while numerical data requires a color scale that blends from one color to another in order to represent the differences in high and low values. A selection of solid colors can be used to represent multiple value ranges. For example, 0 to 10, 11 to 20, 21 to 30, etc. Or you can use a gradient scale for a single range, for example 0 to 100, by blending two or more colors together. Because of their reliance on color to communicate values, heat maps are a chart better suited for displaying a more generalized view of numerical data, as it's harder to accurately tell the differences between color shades and to extract specific data points from, unless of course you include the raw data in the cells. Heat maps can also be used to show the changes in data over time if one of the rows or columns are set to a time scale. An example of this would be to use a heat map to compare the temperature changes across the year in multiple cities to see where's the hottest or coldest places. So the rows could list the cities to compare and the columns contain each month and the cells would contain the temperature values. To find out more information on
Hey guys, Nathaniel here. Let me go ahead and get this started. So we're going to be using the pair plot today. This is probably the most powerful of all of the Seaborn tools that I've used. Perhaps not most powerful, but most ubiquitous of these tools. I use this literally on every single data set that I examine. We're going to be using the iris dataset this time instead of the tips dataset. The iris dataset has flowers as well as a couple of their features. So let's go ahead and show these bad boys. Okay, so the features that we're going to be examining, we've got 4: petal width, petal length, sepal width, and sepal length. So these are aspects of a flower. And you notice it plots their joint distributions as well as their marginal distributions. The joint distributions are, of course, on the, triangles of this matrix. And the marginal distributions are down the center. The marginal distributions, histograms to begin with. Joint distributions are scatter plots to begin with. So this is pretty cool, pretty useful. Notice that these you basically just invert the axes and you get the exact same diagram. So this one is sepal width by sepal length, and this one is sepal length by sepal width. So super useful, incredibly useful for looking at correlations across multiple, well, again, just a dot core would also do it, but looking at relationships between these things across multiple dimensions. So pretty cool, pretty cool. You can go ahead and if you have a categorical data set, so if you're trying to categorize these things, you can go ahead and plot their categories. So in this case, we take the hue and the species. So we have 3 species here. So these will be so these will sort of be like the averages of sepal length, and sepal width, and blah blah blah. This will sort of be the reds here will I guess be Virginica, pointed on sepal length and sepal width. So again, you'll notice that most of the Virginicas have longer sepal lengths. You'll notice that most of the Setosas have extremely short petal lengths. So it's again pretty useful. It's again
Hello everyone and welcome to the lecture on pair plots. In this lecture we'll see how we can draw graphs by using pair plots. As usual, we start by importing the libraries and modules that we need. I copied this from our previous lecture. We'll be using Seaborn's iris dataset and the tips dataset for plotting. Pair plots allow us to see the relationship between 2 variables. Let's see an example by first looking at the iris dataset. Let's import the iris dataset by using the load dataset method. So sns.load dataset, then we'll pass iris. And let's save this in a variable called iris. Once we have that, we'll call the pair plot method that Seaborn has. So sns.pairplot, and then we simply pass our dataset, which is iris, and run it. So this is a nice pair plot representation of our iris dataset. I will zoom out so that you can see the entire graph. So here on the x-axis we have sepal length, sepal width, petal length, and petal width, and we have the same variables on the y-axis.